Well, last time I was here we were talking about dropping the voltage down from 12 to 6 volts, and there was a couple of ways we could do it. We were looking at using a simple resistor, but we weren't sure that a simple resistor would deliver the current for the startup for the motor. So a few people said, well, we'll build a regulator, but to be honest I'm going to try using a resistor first, because if a resistor actually works, then what's the point in doing anything more complicated, because a resistor is very simple. So yeah, let's put a sock in it. In fact, let's put 2 in it. Well, I had a look in my junk box. I haven't got any 1 ohm resistors, I've just got some 2 ohm resistors, so I've just strapped 2 together in parallel. And we're going to actually need about resistors about 35 watt, because we're we're trying to dissipate 6 volts at 5 amps, which is it's about 35 watts, isn't it, something like that. So these we've got 4 watts of wattage here, so these are going to burn out, so they're not going to last long, but hopefully they'll last just long enough for us to do our test. So let's see what the voltage will be. Obviously too much. Right, about 5 volts there, so that'll be fine. I'm trying to wonder if it works better one way than the other. Ooh, I think we could hear the effect of those resistors heating up there. They are very toasty. Yeah, I think that'll be okay. So we want a 1 ohm resistor, don't we? It does seem like setting the motor so it strikes the diaphragm, it seems a little bit critical, so I don't know if this will stay in adjustment when it's in the car. I don't know, we've got to try it, haven't we? It'll either work or it won't. So we're going to go ahead with, we're going to get a 1 ohm resistor, and we're going to get a power resistor. I think the next size up, I think it's 30 watts and then it's 50 watts. So we're going to get a 1 ohm 50 watt power resistor, one of those alcohol type resistors that's got the the aluminium can on it that you can bolt down to a surface. We'll order one of them from RS, and we'll give it a try with that, see if that works. You saw me earlier designing a little bracket for this Ahooga horn, and I've gone ahead and I've printed it off, and I'm going to use this as a template to actually cut the bracket out of steel. And you can see we've got this red box here. Well, that red box here, that's where we're going to put a power resistor. And I just basically roughly calculated that a 1 ohm resistor, we wanted one about 30 watts, but couldn't find any at 30 watts on the RS website, so the nearest convenient size was 50 watts. So I've ordered one of these aluminium bodied power resistors, and I'm going to bolt this to the bracket. and we're going to use that power resistor to drop from 12 volts to 6 volts. Some people have said, well, you probably don't need a resistor, it'll be alright, but yeah, I think I'll be happy with a resistor, and it's just going to take the the worst of the current away. It's just going to be a bit easier on the motor, isn't it? So that's what we've got to cut out anyway. So these are the mounting holes here, and we're just going to pick them up like that. And I think what I'm going to have to do is I'm going to have to make this bracket a little bit longer. I'm going to put a fold in it, steel, like that, and then I'm going to drill 2 holes, and these are the 2 holes that we're going to bolt down. In fact, it's not going to be far off that. Not sure if you'll be able to see me, but this is going to mount something like this. The bracket's going to go about here like that. Hopefully you can see that, which is roughly where the original ones were installed. So what I'm going to do now is an awful lot of punching. Hopefully that should have transferred a pattern, which has. You can see that. Now this piece of metal is about 3mm thick, so it's quite heavy gauge stuff. So of course you need really quite a big pair of scissors to get through that. So I'm just going to cut this out, and I'll bring you back when I've done it. So we've cut out our metal bracket, and we've just got to drill some holes now for the mounting brackets. And we've actually got to drill 3 holes, because there's 3 studs here, and then there's a partial screw which just sticks out the back. So we're just going to drill a hole for clearance for that. Oop, drill got stuck. And what we've got to do next is we've just got to mount our power resistor, which I think I'm just going to tuck under it. So we've drilled our mounting hole for the resistors, and we've deburred it, and that's going to go on there, something like that. I think it'll fasten on with something like just some M3 metric screws. So that's what we'll do. That we'll bolt that on. Well, the next thing we're going to do is we're going to put a fold in it. We need to fold it because it needs to be at a right angle. This, the way it's mounted in the car body. We're going to have to put a fold in it somewhere. And I actually want to put the fold in it so that you can't actually see the resistor. We're going to put that on the side that's hidden, so effectively the resistor's going to go on this side like this. I'm not dead sure this folder's got the capabilities of folding this, but well, we can but try. If it doesn't work, we're going to be putting it in the vice and smacking it a lot, which also works. Wish I was a bit taller. Yeah, I think with something like that. Will that do? Not too bad. So it's starting to come together, this now. Oh, I've bent a little bit over 90. That may not matter. You know, this folding machine really is quite evil. You've got to be very careful how you carry it, because it all kind of moves. it moves, and when it moves it swivels, and it's really good at trapping fingers and hurting you. This finger's bitten me lots of times. Now, I don't know if you lot are going to be able to see in, but that's just bolt there, and I think that'll be okay actually. Does it want to point to the front? It probably doesn't really, does it? Probably more like to get water in it. I think as long as it points down there, I mean it's pointing towards the exhaust, but I can't see that being a problem. I think it'll be under the bonnet level here, so I think this is going to go there. So I'm now quite happy with that. What I'm going to have to do is I'm just going to get somebody to hold it while I've got some holes drilled in the body, and I'm going to have to mark them on here. But unfortunately I definitely can't do that. That's definitely a six-handed job. So I think that's all I can do for now, so I'll get my good lady to hold that for me and I will mark it. Might actually be worth taking a bit of the bend out of this bracket a little bit, because I think it might be better. At the moment it's stuck out a little bit, and I actually think if we took a little bit of that bend out it might point down. Well, it would point down. I think that might actually be preferable to have it just pointed down a bit more, so we'll take a little bit of the bend out this bracket. That's not too bad, but I think we'll have to give it another coat. So here's our power resistor, which is newly arrived from RS Components, and for those playing along at home, it's a 1 ohm, and it's made by a company called TE, and it's a HSA 50, so that just means it's a 50 watt resistor. So we can get rid of the temporary resistor that we had before, and we'll try this. And that's hoogering quite nicely, isn't it? I can actually hold this resistor, I can feel it getting warm. But we're never going to actually have the horn going for that long, so that's about perfect, isn't it? I'm getting about 6 volts on the meter there. So here's the bracket that we made yesterday, and I think that's looking quite splendid, all dressed in black, isn't it? And what we've got to do is we've just got to fix our resistor onto it. We're just going to bolt it on using some little M3 bolts and nuts that we've got. Hopefully I might find some nylock nuts to use. And I did think that we could maybe put some of that heatsink compound on it. Maybe we'll put a little blob on the back here so it's got some good thermal conduction with the bracket, but to be quite honest, I don't think it needs it. I don't think it's really going to matter that much whether or not we put heatsink compound or not, because it's not going to be running very long. You know, it's got a very low duty cycle. You honk your horn for a second and then you don't honk it again for a few days, hopefully. So yeah, I think we probably don't need any heat sinking compound on there, so we'll just get it bolted up. Well, I keep 2 sizes of bolt in stock. We've got 2 long and 2 short. I very much doubt we've got the bolt that I'm looking for, because what I'm actually looking for is just right. I think we're all out of just right. Actually, these might suit a nylock nut okay, actually. So we've got a 5BA spanner here. It says Terry's spanner, made from tempered steel in England. It's got 5BA on one side and 4BA on the other. And as it happens, that just seems to fit this this M3 nut quite well. So there you go. I know some of you like to have a close look at these things. That's not bad. I suppose if we were being a bit picky we could have lined them screws up, couldn't we, so they were both in line with each other, but I'm not that picky. I actually think that looks okay. Still got the remains of my pot marks that I put in down there. Probably went a bit mad with the pot marking, putting the little dots in it, but to be honest I was enjoying myself, so I carried on. Well, I think the last thing we've got to do is to actually solder some wires onto the lugs of this power resistor. So one of the lugs is going to connect to the horn terminal, and the other one is going to be the incoming supply, which is fed from the relay, which is screwed to the bulkhead on the Chevy Truck. So let's go ahead and solder some pieces of wire on and put some adhesive heat shrink over them. Well, I've just been rooting around under the bench trying to find some wire, and I don't have a lot of heavy gauge wire. This looks as though it's about 2.5 square millimetre. It looks like it's probably something like tri-rated control wiring out of a panel or something like that. So we're going to have a go at we're going to solder that on. I think that's what we're going to do. So it's going to sit in the truck something like that. So we're going to need I think the main supply is going to come in from this side, and then so we're going to need a loop of wire which comes out of here and goes to that terminal up there. So let's do that one first maybe. So what do we want? Back in the day when I used to do electronics for a living, I always used to like tinning wires. It probably wasn't very healthy, but we used to have those solder pots, and you would have a pot of flux and you'd dip your wire into the pot of flux and then you'd dip it into the solder. Sure, it's probably really carcinogenic, but I don't know, I used to really enjoy fixing wires on, tinning wires. Very great fun. Yep, that's a full joint. We've got that all the way around. Now I know a lot of you don't use fluxes, but well, it's fair enough, every man to his own, but I think that if you're doing especially things that have got big terminal posts and stuff like that, and maybe more if you're working on vintage equipment, you know, old tape recorders and valve radios and stuff, because all the terminals are so dirty because the stuff is so ancient, just the flux, the main advantage of it is it takes the solder quicker, and that's a good thing because you don't want the soldering iron on the component for any longer than it has to be there. So there's a big advantage to flux because it cleans all the metal off, and it means you can just get in and out really quickly. Probably a little bit too much solder on there actually. Maybe, see that? There's a little bit of a drop of solder. Don't know if you can see that, but there's a kind of a bit of a blob of solder here at the bottom. A little bit more solder on there than we need. I overdid it a little bit, but it'll be okay, all good. Now hopefully this will shrink down enough, let's see. Yep, that works. Just remember to pull these socks out before we go down the road. So I've gone ahead and I've fitted a couple of washers, and one of the washers is a shake-proof washer because we don't want this bracket coming loose as we're going down the road and our Ahooga horn rolling down the road behind us, do we? So hopefully this should keep it in place. So hopefully now this is ready to reinstall back in the car. We've just got to connect this wire up, haven't we? So maybe we could go ahead and do that as well. Right, it turns out I've got a screw loose. I think you already knew that, didn't you? Yep, that goes in there nicely. Seems to grip it. And this end's going to need a male bullet crimp on it. So we may as well go and install that. And that's going to be the positive feed to it. That looks alright. I'm guessing the final thing we're going to have to put on it is actually a ground connection. And I think I'm going to ground through the bodywork on the vehicle, which is always a bit of a pain because I've got all this lovely paint on it. I'm going to have to scrape some of that off probably. And I think we're going to be using these bolts, which are a UNF, so I've got to find a ring crimp that will fit on that. I'm going to have to scrub off some of our lovely paint because we need to get a good air connection on this. Yeah. Go on, do it then.
Perfect.